Now, let us go and do the Colab notebook. So, here I am going to be installing, right, the data sets. In this case, we are taking simple English data set from our lab. It is an English data set. We have other data sets. If you go to a lab, you can see all of this. The lab website that I showed, ASR IITM.ac.in. Then we are going to use transformers, right, because remember wave to wake itself is a transformer based kind of approach. Then we have to evaluate, so we will use Jiver, which is going to give you the word error rate. So, first we will have to incorporate and make this install all these things, the transformers, the Jiver and all. Okay. It is taking some time, but you can see that what happens, is it connected? Yeah, it is connected. Okay. So, if you see here, okay, that's the trivial part. Okay. Then we are going to also import, we have to import torch and all that. So, we are going to import that. So, we are going to import all these other things. Okay. So, remember here what have I done? I am also introducing something called wave to wake CTC, wave to wake feature extractor, wave to wake. Remember, I gave you some broad overview. Wave to wake is like a kind of feature extractor. It is a pre-trained model whose features will help me get better performance when I have very small amount of supervised data. Okay. So, we are going to do that. So, we are getting all those, importing all of those things. Okay. So, let that finish. Then we have a small data set that we have stored in here, right. Our lab is called Spring Lab. So, that is why it is from Spring Lab and it is a ASR task data. You can even explore this task here, right. So, I am going to go to this task, right. So, these are the, remember this is a supervised data set that we have created and put on the internet. Okay. So, whenever we have ASR task, there is the audio and the corresponding text. This we have taken from some our technical lectures. So, for example,
block which let us get this one running. So, the simple part is just go over there and then you.
So, this is the audio part and the supervision, somebody has listened to this audio and typed it here. This is not automatic speech recognition. We are going to use this data to train the model. So, this is human supervised transcription that we are going to use and fine tune the wave to wake model to get a very good performance. So, this is example of another.
You have run selected cell. So, we select that one and run it. So, while it runs you would.
Okay. So, this is the basic idea of what is called a supervised ASR task. Okay. And therefore, we are going to download this task here, right, from Hugging Face basically. It's a very small data we can make. I mean, on our website there is a lot of big data. So, we have taken a small subset. So, if you go to the big if you want to do the entire, so with small data set the performance will not be that good. Okay. So, you have to live with it, but if you have time at home and you have enough thing, you can actually download a bigger data. So much data is available on our website. Okay. So, we are taking a very small amount of data, ASR data. Okay. And then what we are going to do is we have to train. So, you know how we train all these deep learning methods. So, the first thing is we have to batch it, and remember what is the target here. I am directly going to what is called end to end speech recognition system. So, given the speech signal, instead of going through the phonemes and all, I directly output the characters. Okay. Therefore, I have to, that is the target. So, therefore, I have to understand what are the unique characters in my vocabulary, right. So, this is something that I am going to extract, because in the training set I have to train the system. So, the output I should know what are the characters present, right. So, that is why I am extracting all these characters, right. Then I am creating a vocab list, right. So, this is all the characters. So, this is the vocab list we are doing, okay. And then we are creating this kind of a train data set. Okay. Oh, what did I do? I missed out one set, sorry, I forgot to import. Okay. I mean, you can, there's enough instruction, some documentation to tell you what that each step is. I mean, these are basically, we are just creating basically what are the characters present, because I have to train the network to predict these characters, right, and basically through CTC, and we are going to just, you are just processing the data, the training data, right, and we are adding, see, sometimes I might have some unknown, some new character might come, right, it might not be in my vocabulary. So, I have to understand that this is possible, and the system should not just break down if it sees something which has never met before. So, we say okay, pipe it all to basically unknown character. Okay. So, that is all you are doing. Now, we are getting this important wave to vec guy, right. So, this wave to vec guy is already pre-trained, it is already kept on the internet. Okay. So, you do not have to do anything. So, this is like somebody has pre-trained a BERT model and kept it. Here the wave to vec model has been trained and kept. Okay. But how to use this model? We need certain inputs to the wave to vec. So, that is why we are preparing this wave to vec kind of a thing. Okay. And now, I am going to actually extract the features for our trained data, right. So, this is what I am going to do. I am going to pass this trained data through the wave to vec feature extractor, and I will get all these embeddings for this particular trained audio, right, audio coming from the train set. Okay. And then I have the wave to vec processor, right. So, and then now I am creating this paired data, the supervised data, where one input will be the wave to vec embeddings, and the output will target is what? Characters. We want to recognize the characters. From the characters, I can create the words, correct? Okay. Then I am going to do batch processing, right. So, every batch I am going to okay. Okay, this might, I should have not taken so much data, I should have stopped it. Let me see if it is going to take too much time, I should take a subset of the data. Okay, let this run. Okay, so don't worry too much about it. I mean, you at home you should be doing it. It will take some time because we need to do this, right? So, and then I'll explain the other steps, and then it will take some time. It's not going to. It will still take some time. I've not even done a quarter of the data. Okay. But let's wait and do it, but I'll explain the other steps. Okay. So, basically now this is basically the the data batching that I've done here. Okay. So, now what I'm going to do is basically to pass this through a wave to vec processor, right. Remember I told you that I need two parts, right. So, this is the first part, which is the input, the features that are coming from the wave to vec. Okay. And this is the target, which is basically the characters that I have to output correctly. While training, I will be giving the correct characters and asking it to predict, and whenever it is making mistakes, there will be a loss, then it will back propagate and update the parameters of the network. So, this is the step that we are going to do. This is what I am exactly doing here. So, the the label set and the feature set, right. So, this is what I am going to do, and then I am going to, I have to pad it. Remember that we are creating, when you are creating a batch, they all will be of different sizes. So, we are going to pad it at the end. Okay. And then we are, remember I am talking about the error metric. In this case, the error that I am talking about is the word error rate, which is a combination of all the substitution errors, the deletion errors, and the insertion errors. Okay. How much have I finished? It's still at 25%. let's wait up, let's be patient a little bit. Okay, I'll show you the other steps and then we'll see how much we can do it. Okay, and therefore we are going to then compute the metrics. Okay, and this metric is based on the errors made, right. So, there will be prediction error, which can be substitution error, deletion error or insertion error. Based on that, we add up all of those 3 errors, divide by, take percentage terms, that will be the word error rate percentage. And then train data, we have taken the train set and split it into 0.1% or 10% of the data as the train test split. Okay, and we are just seeding it with some random number. Okay. So, then we are going to just pass this through the wave to vec. Now, wave to vec, the model that we are using is one, because we are using only English, we are just borrowing it from Facebook. Facebook has built already a pre-trained model, wave to vec. For Indian languages, for example, we have a large amount of data ourselves, right, which we have built. Okay, and you can see it yourself. Okay. So, you can see download models. These are models that we have built for Indian languages. Okay. This is built by us, you can download it. The wave to vec that we are using there was built by Meta and kept in the open source. We have built for Indian languages, we have used about 30,000 hours, and these two approaches of pre-training is something that has been proposed by our lab, and these are some of the best performing systems right now for Indian languages. Okay. But there are other techniques like Hubert and data to vec itself, and wave to vec is what I am currently showing you. Okay. Okay. So, okay, so we are going to use CTC loss and blah blah blah, we will come to that. Okay. Then we are going to freeze the encoder, that is, I am going to treat the wave to vec as a feature extractor. I am not going to update the parameters of that. This is the training argument. We are using a batch size of 8. We are going to run it for 7 epochs. I will have to reduce it because I want to quickly finish. Maybe I will run it for 2 epochs. The word error rate will be very high. And then the standard steps, what is the learning rate? We are used a very small learning rate. Then we are using warm up, right, about 25,000 steps of warm up, and we are going to keep the best model and so on. Okay. And then we are actually going to train the network. Okay. So, that is the training part of it. And after we have trained the network, which is going to be done now, you are going to also evaluate it after it will run. We are trying to run for 7 epochs, but in my case I want to reduce it, so that we do not run it for more than. So, in the interest of time, I am just waiting to see if I can. The network is slow here. So, but I mean, you can, I mean, if you read the comments itself, it should be pretty clear to you. Okay. So, basically we are going to use some pre-trained model and fine tune it with this data that is the supervised data, right, small amount of data. Where did we got it from Spring Lab, somewhere it is there, right. The Spring Lab data, it is there in Hugging Face, right. So, we are going to take that data, small amount of English data, you saw that data here, right. So, some data like this
images itself, and these are all color RGB color images. So, that is available directly within.
Okay. So, and then using this we are going to build an English, but now it will be Indian English speech recognition. There are different accents, right, American English versus British English versus Indian English, Australian English, right. So, we are going to use this to build an Indian English model. Okay. And unfortunately it is taking a lot of time. It might take another 8 minutes. So, I am just thinking, since it is done so much, I will just reduce the reduce the batch size. Of course, that is very bad, right. Even here, if I run it for more batch, more epochs, and I will get better performance, but I want you to see. And actually, once you train this network, right, you can even upload some, you have a trained model here, and I am trying to give some batch test data, batch audios, right, a batch of few audios, and it's going to assess or evaluate the word error rate. But you can even give a single audio. I mean, so these are things that you should practice here, that you try to give a single audio and see whether, or you can record your own audio, use it to use this model that you are building, and see how well it is going to output, right. What I showed you here, I mean, we also have English model, I am sure somewhere here, right. So we also have English models somewhere here, I am sure. Demo English model is also there, right. So English. So hello, how are you? I am trying to speak in English. This is an automatic speech recognition experiment. Okay. So you can see this is very good. Okay. So we have of course built with a lot of data, right. And so hello, how are you? So you can see. Hello, how are you? I am trying to speak in English. This is an automatic speech recognition experiment. Okay. So, so nevertheless, what you get will not be that good, because few things. The data is very small, even though you are using wave to wake. This is just an experiment. If you have enough compute power, you can take, again we have also data for you, right. I mean, data is also available. So, we have publicly released the data. Indian English data is not here, but you can use some of this. These are all Indian English data. Okay, English 110 hours, English 190 hours. If you have all this data, you can actually build a very good model. Okay, and the model that you are showing is kind of built on these kind of data, right. And you should get the kind of performance that we are talking about. Okay, it's almost, you should be able to with the kind of setup that we have, you should be able to do. Again, now is wave to wake, the one that is used from Meta is built on American English mostly. So you can try to use other pre-trained models. There is something called wave to wake, the XLSR version, that is the multilingual. So it has different accents also captured, different languages also captured. Then there is another data called MMS, again from Meta, which is massively multilingual speech. All these are from Meta itself. Then Hubert is also there, which is again from Meta. Again for Indian, including Indian English, you can use our own one that's built from our Spring Lab, from Indian language data that we have collected. We have our own pre-trained model. So you can try any one of these and play around with it to see how well your speech recognition system will work. Okay. I don't think it's done at all, right? It's just it's still very slow. The network is very slow, but you should just I mean, these steps that you're running, there's enough documentation. For example, it's telling you what it's trying to do at each step, right? So for example, right from the beginning, right, this function takes data as input. Each data it concatenates into a batch, right. It then creates, remember our purpose in all of this is to convert the speech into characters. Characters itself concatenate to form words, and blank spaces between the words help us distinguish words, right. So basically only thing you have to worry about is recognizing characters. This is the end-to-end speech recognition system. Normally in the olden days we would go through phonemes, then come through lexicon and language model, but today's modern end-to-end speech recognition systems directly go from speech to text, and therefore the target is only the characters that you are worried about. Okay. And then vocabulist is used to hold, so this is the vocabulist you are talking about. It's used to hold all the characters. So you are going to give some bunch of data, right, training data. So it's extracting for that bunch of training data what are the characters that are there. It's stored in the vocabulist. This converts vocabulist in a set to remove any duplicate characters, blah blah blah. So it's telling you, then it's creating a dictionary of vocabulist. Okay. So it's doing all these things. So it's also if you want to understand more about the wave to wake feature extractor, you can click on this, and then you will be actually it will describe to you what is this wave to wake, that black box that you are giving, what are the different things you can do, the different inputs, right. So all this is in Hugging Face. So you can even go, if you click on this link, it'll just tell you what is happening where, and then what is the wave to wake processor, right. Basically you are having a model, but how do you feed parameters into the model, what should be the output of the model, where will you get, and so on and so on. Okay. So therefore this should be done in another 2 minutes. So shall I wait? I will wait. So if you bear with me, okay, then the other steps, what I am going to do is definitely kind of reduce the the batch, the number of epochs. I'll make it 2. You will get a very, say, deep, what are we doing when you're running through epochs? You're going through the data, and every iteration basically you collect some gradients, then you update the parameters, right? Then you again do a forward pass, get the loss, then you back propagate. You're going to do it a large number of times, right? So every time small incremental change in weights is going to happen. The question is, how many times, the more times you run through the data, you keep doing it until there are no dramatic changes. Usually we use something called patience, so that from every iteration to iteration, if the parameters are not changing significantly, it will stop by itself if it has not changed in the last 4 or 5 steps. But sometimes you might just count the number of epochs and say stop after 3, 5, 10, 100, 20, 200 epochs. So I'll just the more epochs, depending on the task, you don't want to overtrain also. So and this model freeze feature encoder, you could use 2 ways the wave to wake. You can update the parameters of the wave to wake also. It will improve the performance even more, but the kind of data we have is very small. So we may not want to, we are going to not, with very little data, if you are trying to update the wave to wake, it might get badly, it might move in the wrong direction. So see, any fine tuning, there is going to be some forgetting that's going to happen. So we want to keep the features, the encoder part fixed, so that it doesn't do quote unquote catastrophic forgetting or something like that. Okay. So that's the reason why we are feeding with, we are saying don't update the parameters of the wave to wake. Okay. Treat it as a feature extractor. Okay. So it's almost 7,000 out of 8,000 is done. So if you bear with me for another 3-4 minutes, we should be done, and then I'll just go through and I'll just make this 2 epochs. Okay. So I'm going to make it as 2 epochs. Even that might be significantly, we'll see. Okay. Otherwise, I'll sort of stop it, so that you get an idea. Okay. This usually, once the preparation is done, okay. So this is the third experiment. So remember, in speech you can do multiple things. The fourth experiment I will try to do is try to give the opposite of this, that is text to speech. So if I type, so here when I speak, you are getting the text. In text to speech, when I type the text, you are going to generate the voice, right? So so that is the opposite exercise. So I can again show it to you. So we have enough. So let me just type something, so that I don't know how to type all these languages. So let me just type in Hindi, say something, then I'll carry it forward. Okay. मैं हिंदी में अच्छी तरह से बात करता हूँ. Okay. So let's say I am able to do this, right, instead of typing. So this is a text that came. Okay. Now I can go and synthesize the text, right. So I can now put it as, of course my voice will not come, this is the voice on which the TTS will be trained, right. So so let us see how it sounds.
मैं हिंदी में अच्छी तरह से बात करता हूँ.
Okay. So, basically the opposite exercise, that is the TTS, we will again do it next class or next week, but that will be it is not exactly the opposite. So, we will have to the ideas are slightly different. So, and people get annoyed if the text if the voice is not good. So, we have to choose some nice radio jockeys voice. So, normally these are recorded under studio conditions and prepared data for TTS. Okay. So, it is almost 100%. So, we should be done with it. Okay. I mean, just to motivate you all, speech is very important and very valuable kind of input, because speech is very natural. All of us can speak, but writing is something, a skill that you develop, you learn in school, right? Reading is a skill that you actually develop later in school, right? So, it is somewhere literacy comes into the picture, right? And on top of that, if if for example, I am an old person, right? For me, typing something on the mobile keyboard is something very difficult, okay? Whereas youngsters, even without looking, you can type it very easily, right? So, speech is something that is more easy, and you don't need reading, writing, keyboarding skills, and therefore, it's much more natural for India, because we have so many languages and all of us can speak. And the idea, I think we should think of is, after doing all these courses, is to come up with methods that where people can speak and get lot of their work done just by speaking, right. So, if I want to do a train booking or something, right, I do not, even if I have to go to the IRCTC website and I have to enter so many things, I have to read to understand what it's saying. But instead, if I can just take a mobile and say, IRCTC mein aapka swagat hai, welcome to IRCTC, where do you want to go? I want to go to Mumbai, from which station? Chennai, right? Then what day? So there's a conversation that can happen, and then we can, the system through speech itself can book a ticket for you, okay, and then it can send by SMS or WhatsApp the ticket to you, right. I mean, as long as you have a registered mobile number and so on. So this has been done. So it's basically the task. Remember, the 100% is done here. So let me see if I can. You will get some very bad word error rate, but if you're patient and if you have enough data, you should be able to build a good system. Okay. So, in fact, you can use this as a black box, right, and just change the data, right, and you should be able to train it very well. Okay. So, I am running the steps. So, right now it is basically just taking this PyTorch, so this is the model, CTC model, where which model am I taking? I am taking Facebook's own wave to wake base model. So, this is a model that is freely available. Like as I said, they have better models like XLSR. You should just change it. It is there in what is this called, Hugging Face, there is MMS, there are so many models and all of them are better than this. We just picked up one model, so you can choose anything, right. You can even, I mean, ours is not a very good model for English because it's trained mostly on Indian languages, but you can take our own wave to wake, but that's not in Hugging Face, but you can try to put it and get it working, okay. So, now I am going to train the network, okay, and so remember I made this only 2 epochs, okay. So, I am going to do only 2 epochs. This itself will take some time, but let us see what happens, okay. I think I will try to stop this, but this is the last step, okay. It will take some time, okay. It's not going to be, but until at least I needed to do something like this for you to see some, at least some reasonable output, otherwise it will just give 100% word error rate, okay. But this itself might take some time, okay. But if I might have to stop because it's already late, okay. So, okay, so it's going to do the training and then the test also is incorporated in that. So, it should give you some word error rate, okay. I'll just allow it to just output something at this step, and then you should be able to, if it's not also, let me just just give me a couple of minutes, otherwise we will wind up. Okay. So, as I said, you can do lots of wonderful things. You can change these models, right? All these are good things to do, right? You can change the data, right? And see, the steps remain identical. Okay. So, you should be able to try many different things, see which one works better, which one doesn't work better, and so on. Okay. So, I think this is just. But you have to be patient at home. If you want a decent performance, you should be willing to spend some time for the model to train. I've kept the epochs too low. Two I've kept it here, but you should keep it at some higher number. Okay. So, I will stop here. The last step, it will just train and then give you the word error rate. And then you can also try, if you can take this model and try to give some audio input and see what output will come. Okay, the text should be reasonably close to what you said. Okay, not perfect, but because the data is very, very small. So, thank you very much. So, next class I will talk about the opposite, which is the text to speech. Okay, thank you very much.